right? So for example 4, we have a odd cosine and an even sign. So we can go to our little chart. If you want to start from the top, that'd be cool. So the first thing that we see is odd sign. There is no odd sign. And then we have odd cosine. We do have an odd cosine, so you could try this first and see what happens, okay? So if we were to do it this way, I'm just gonna show you guys why this doesn't work. I think I have a sheet of paper where I tried it like 3 different ways. Let me see, what is this example 4? Yeah, so what did I do? I did odd cosine. Yeah. So I did odd cosine just because I saw odd cosine and I didn't see odd sine. I feel like there's a way, it might actually go in order where you should try to manipulate it looking like the first to bottom. Unfortunately, I'm not too quite sure, so I've been playing the guessing game, but at any rate, yeah. So I originally tried using the second one just because I saw cosine odd. So if we were to do that, let's see, we'd end up with, we'd have sine squared x equal to 1 minus cosine squared x. We'd have u is equal to cosine x. And then our du, if we take the derivative, would be negative sine x dx. So our goal would be to pull out a negative sine x dx from here. Oh, you know what? This actually might work. I don't think it matters. I don't know. Let me just keep going. It might work. But at any rate, if we keep going here, essentially we want this to show up. So we need to pull out. Oh, that's why it doesn't work. Okay, cool. So yeah, we need this du, which means we only need one sign. So we'll have to take a sign out from here. If we take out a sign from here, that puts us at, so I'm just gonna write cosine x. I'm gonna raise it to the 5th because that's what we have. And then I'm gonna break this into sine x to the 3rd, and then a single sine x dx. Okay, so if we were to combine those, we get that 4 back. This right here is going to help us get our du. If we need a negative, I'll put a negative here and then counteract it with a negative here, okay? So that's fine. So this right here would be our dx. The issue is this cosine x would change to u, but this right here can't be moved using this rule right here. So that's why this isn't the best way to go, and that's why I stopped. That's not to say that it doesn't work. I don't want to say that. I didn't actually try it. Yeah, so essentially you'd have to break that up again into sine squared x and then sine x, and then this would become du. I know this is bad math. You shouldn't have a u and an x in the same problem, but I'm just checking. So yeah, so now we could change this sine squared to this 1 minus cosine squared u, and cosine is u, so that'd be u squared. But yeah, we still have this sine x. So I think that's where the issue really comes in. Right, so that's why we couldn't use this way. So essentially your goal is to create this du within your original problem, and then you want your u in whatever this is, whatever your squared trig function is, to replace everything else. So if it doesn't replace, if your u, du, and your squared trig function doesn't replace every part within the problem, it's not gonna work, okay? So that's why we had to go back, why I had to go back and use odd for sine. Okay, so if we're using odd for sine, that means I need to pull out, that means we're using cosine squared is equal to 1 minus sine squared, and u is equal to sine u. If we take the derivative of sine, that gives us cosine, so that means we need to pull out one cosine from the jump. Okay, so it's going to leave us with 4 cosines, 4 sines, and then I put this other cosine on the end, du, just to get that dx, sorry, so I can make that du, okay? So here we have x, or cosine x to the 4th. We need it to say cosine to the squared, so I'm going to do that squared trick again. This sine x is fine because we know that that's u. And now we can start plugging things in. So this cosine squared x is the same thing as 1 minus sine squared, but sine is u, so this is 1 minus u squared, okay? So that's where this orange part came from. And then sine u is u, so that's why we have u to the fourth. And then this purple part right here is our du, okay? And then we just do regular algebra. We FOIL this part right here, we get this. To get rid of our parentheses, we distribute this u to the fourth to all of our parts, and then we do regular integration where we add 1, divide by that number. And then when we have this integral with no interval, we always do our plus c, right? Our arbitrary number. And then we weren't originally given u as our variable, we were given x, so we have to always go back and change it. So our u was originally sine x, so we go back and plug that in for the final answer.